The circuit diagram below shows a circuit containing batteries and resistors. You may assume the batteries have negligible internal resistance. So no internal resistance. Okay, again, this is a Kirchhoff rule equation. Use a Kirchhoff first law to find the current. Current passes through 6 ohm and 10 ohm. That means you want the I2, the current that passes through the middle branch. And then find E1 and E2. Find the EMF, E1 and E2. Okay? So that's the question. So you must redraw this diagram, yeah? Okay, always when you do the Kirchhoff rule equation, Kirchhoff law equation, you must redraw the diagram. Redraw the diagram and then label the EMF and also label the current, yeah? So first of all, label the EMF. So E1 negative to positive going to the left, E2 negative to positive going to the left, okay, negative to positive, yeah, from negative to positive, yeah. This is E2, and then label the current. So the current I1. Actually I1 is from B going to A, yeah, this is I1, and then I2 is from A going to B, yeah, this is I2, and then I3 is the one passes through 6 ohm and 10 ohm. Okay, so now build equation. The first law equation, choose junction A. Okay, so junction A, so the current entering is I1, and then current out is I2 plus I3. Actually, the current travel this way. Let's say I start from B. So here I1 goes here from B to A, and then at A break into two, I2 and I3. Combine, I1 break I2, I3, combine, get I1, I3, combine, I1. Okay. So now, okay, so you got the I3 already from the current in, current out. Now do the second law, loop 1, yeah. Use loop 1, yeah, because we want to find E1. So E1 is at loop 1. So the loop I choose anti-clockwise for loop 1. Okay. Now let's look carefully. So total E go to total IR, total E. So we in this circuit anti-clockwise, loop 1 and loop 1 anti-clockwise, we have E1, and E1 is same direction with the loop, so positive E1. Okay, positive E1. And then we have two resistor. This is IR, so the current passes through 6 ohm is I3, so I3, yeah. So 6 ohm is looking at I3, so I3 is same direction with the loop, so also I3 passes through 10 ohm. So I3 is same direction with the loop, so also positive. So 6 ohm and 10 ohm, these two you get positive. You get positive. So the current passes through 6 and 10 is I3 only, yeah. So both of them, the current is same direction with the loop, so positive. Okay. So now you can calculate the EMF1, which is 12 volt. And then, so to find E2, we use another loop, also Kirchhoff second law, loop 2, total E go to total IR. So let's look at loop 2. Loop 2 now is clockwise. Yeah, loop 2 is clockwise. So look at EMF. So you have one battery here, and this battery is same direction with the loop. So E2 is positive. Okay. Now look at resistor. We have 3 resistors here. So look at 6 ohm. 6 ohm is I3. I3 is same direction in the loop, so it is positive. Positive. I3 times 6. And then the 10 ohm. Okay, the 10 ohm current passes through is I3. I3 also same direction in the loop. So for 10 ohm, I3 is positive. So this is positive. Now how about the 5 ohm? 5 ohm current passes through is I2. I2 is opposite to the loop. You see? I2 to the right, then the loop is to the left. So this I2 times 5 is negative. Yeah, is negative. So you get negative I2 times 5. Okay, negative I2 times 5. So we get E2 is 9.5 volts. So that's the answer.